Now we had already understood the different graphs for representation of the motion. So we had the displacement time graph, the velocity time graph, and the acceleration time graph. We know that in the displacement time graph, it not only tells us the displacement, but the slope of the displacement time graph tells us the velocity. From the velocity time graph, the slope of the velocity time graph gives me the acceleration, and the area gives me the displacement. Similarly, in case of acceleration time graph, the area gives me the velocity. So based on these three fundamental things, we are going to have the numericals based on graphical representation of motion. So we start with the first question of the numericals, that is given over here in the form of a graph. So figure shows the displacement time graph for a motion of a body. Use it to calculate the velocity of the body at 1 second, 2 seconds, 3 seconds, and draw the velocity time graph accordingly. So we have over here the first thing, that first numerical. We have got that we can make a table. In fact, it will be easier for us. So we have the time and velocity, this is the displacement time graph. So used to calculate the velocity. So this is the displacement. So first of all, we will find out the values of the displacement from this particular table. So you know that displacement at 1 second is equals to 2 meters. So 1 second, so this is 2 meters. Displacement at 2 seconds is equals to 4 meters, and displacement at 3 seconds is equals to 6 meters. Since it is a straight line incline, so we need to find out the velocity over here. That velocity is over here will be, now velocity is equals to slope, that is equals to y2 minus y1 upon x2 minus x1. So we'll take this as over here as x1 and x2, x1 and y1. Let's take this as x2 and y2. So this gives me 6 minus 2 upon 3 minus 1 is equals to 4 upon 2 is equals to 2 meter per second. Once I get this particular thing, I just need to draw. So for different instances over here, we can find out, or because they asked us that find the velocity of the body at 1 second, 2 seconds, 3 seconds. So all three will be required. So we'll do one by one. So let's not, we can directly take over here the velocity over here. V velocity will be for 1 second will be 2 upon 1. So that will be 2 meter per second. Then the next one is 4 upon 2. So it is 2 meter per second. And the third one is 6 upon 3 is again 2 meter per second. So we can see that for the time period 1 second, 2 seconds and 3 seconds, the velocities are 2, 2 and 2. So accordingly we can form the graph. The graph is already given to you over here. So you just need to mark this on the graph. This is the time in seconds and this is the velocity in meter per second. So this is given as 1, 2, 3, 4. So at 2, you got the first one at 2, second one at 2, third one at 2. So this gives you the this is the graph for the given question. Okay, we see question number 2. Following table gives the displacement of a car at different instances. So they are given the time and displacement 0, 1, 2, 3, 4, and there's 0, 5, 10, 15, 20. You need to draw the displacement time graph. So you're going to take this forming over here. You can draw it in your notebook itself. No need of any graph paper. Take this measurement as 1 centimeter. So 1, 2, 3, 4, 5. This is the time. And this over here, each and every ruled line, you take it as over here displacement, that is 5, 10, 15, 20, 25. Okay, this is each and every ruled line over here. Okay, you are taking the scale over here as one line, 1 centimeter is 5 meters. So this gives me the first one as 1 ka 5, 2 ka 10, 3 ka 15 and 4 ka 20. This gives me a straight line like this as the resultant displacement, displacement time graph. Now from this you need to find out what will be the displacement of car at 2.5 and 4.5. So what we are going to do is that this point over here, so we can see that this point over here is 2.5. You are just going to carry this upwards and then take it sideways. You will find that this will be at 12.5. Similarly at 4.5 you just take it upwards and then you take it over here. You come to know that it will be at 22.5. That is the midway between 20 and 25. You are going to get this. Midway between this and this is going to be this way. So accordingly you find over here that first of all you need to find out the average velocity also. So first thing is velocity is going to be equal to, now you can take any two values. So take this value and this value. So it will be 20 minus 0 upon 4 minus 0 is 20 upon 4 is equals to 5 meter per second. This is the velocity. The second thing is average velocity. Yeah. The second thing is about this part. So first one is at 2.5 seconds. Displacement is 12.5 meters. And at 4.5 seconds, it is 22.5 meters. This is from the graph directly, no calculations required, directly graph mein corresponding displacement which is there, you just need to find that thing. So no calculations anywhere. We come to question number 3. Okay, question number 3. A body is moving in a straight line and its displacement at various distances are given in the time. So you need to plot the time graph and then answer. So first thing is time and displacement. It is 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. And here 2, 6, 12, 12, 12, 18, 22 and 24. So let's draw the graph first. We are taking over here 0, this is the time and this is the displacement. We are taking here as 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So accordingly you need to take the lines in this way, and here 1, 2, 3, 4, 5, 6, 7, 8. So this was the graph structure is ready. Now 0, 2. So 0, 2 will be here. I'll just take the other color. This will be 0, 2. The next is 1 and 6. So 1 ka 6 will be here. Then 2 ka 12, 2 ka 12 will be here. 3 also is 12, so will be here. 4 also is 12, will be here on 12 itself. 5 is 18, so 5 is over here, it is going all the way up to here to 18. Then 6 is 22, so it's coming up to 22. And 7 is 24, so that's up to this point. So when you join this thing, it will be going to be this way. This is the required graph. So plot the displacement time graph and calculate. First, distance travelled in interval 1 to 5. So distance travelled from interval 1 to 5. So from here to here, what is the distance travelled? So distance 1 to 5 is equal to, now at 5 seconds it was at 12 meters. And at the start it was at 1 meter. So 1 to 5, right? So 1 was at 6. 1 was at 6. So It is 12 minus 6 is equals to 6 meters. Try to understand this thing. It is 1 second traveled in between 1 to 7. So 1 second ke baad mein it was at 6 meters and 5 is at 18. So 5 is at 18. So it is 18 minus 6. So it is 12 meters. Try to understand this thing. They asked us to find out the distance traveled between 1 to 5. That means at the time when it was 1 second, where was the body? The body was at 6 meters from the start point. So then, at the point of 5 seconds, after 5 seconds, where was the body? It was at 18 meters away from the start point. So what is the difference between that thing? So 18 minus 6, that is 12 meters is what it travels in 1 to 5. Okay, that was the first answer. Now average velocity in the time period 1 to 5. So we have over here average velocity. Average velocity is equal to total distance upon total time. Total distance how much? 12, we already know this. And what is the total time taken? 1 to 5 is 5 minus 1 is 4. So that is going to 3 meter per second. So 3 meter per second is the average velocity, because average velocity is total displacement or total distance upon total time taken. So total displacement is 12 meters, we found out. What is the total time taken? It is not 5 seconds, 5 minus 1. Why? Because it is between 1 to 5. So 1 to 5 ka between ka matlab hai 4 seconds. That is 1 say 5. 5 minus 1 is 4. So that is 3 meter per second is the answer for question number 3. We move on next to question number 4. Okay, question number 4 shows the displacement of a body at different times. Calculate the velocity of the body at it moved from time interval 0 to 5, 5 to 7 and 7 to 9. Calculate the average velocity during the time interval 5 to 9. So I'll better draw the figure so that you are able to understand it better. So this is 1, 2, 3, 4, 5, 6, 7, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Till 5 seconds is 3. So it's like this. That is a flat to 6 and 7, and then rises up to 7 for 10. So this is the graph what is given to us. Now let's see. So this is the time and this is the displacement. Now first thing is calculate the velocity of the body at time interval 0 to 5. So 0 to 5 velocity 0 to 5 will be equal to y2 minus y1 x2 minus x1 will take the same thing again. So it will be y2 minus y1 is 3 minus 0 upon 5 minus 0. Did you understand this? 3, the y is nothing but the displacement. So 3, this point over here is 5 comma 3 and this point over here is 0 comma 0. So this is my x2 y2, this is my x1 y1. So y2 minus y1 is 3 minus 0, x2 minus x1 is 5 minus 0. So that will be equal to 3 upon 5 is equal to 0.6 meter per second. First ka A. Second is 5 to 7. So velocity 5 to 7. 5 to 7 is over here. So this point over here is nothing but 7 comma 3. So it is nothing but 3 minus 3 upon 7 minus 5. That is going to be 0 upon 2 is equal to 0 meter per second. That's the second part. Third part. Between 7 to 9. So velocity between 7 to 9 will be equal to 7 to 9. So what is the point at 9? Sorry, this was at 9. So take it as 9. So 7 to 9 we find over here this point is nothing but 9 comma 7. So it will be 7 minus 3 upon 9 minus 7, which is nothing but 4 upon 2 is equal to 2 meter per second. Is it clear? Now we ask the average velocity between 5 and 9. So second one is average velocity between 5 to 9. What is the total distance traveled? 5 to 9. This was 7. 5 is 3. So it is 7 minus 3 upon 9 minus 5. So 9 minus 5 is equal to 4 upon 4 is equal to 1 meter per second. Is it clear? Total average velocity is total displacement, total time. What is the displacement at 9 seconds? 7 meters. What is the displacement at 5 seconds? 3 meters. So total displacement is 7 minus 3 is 4. Time taken is 9 to 5. 9 to 5 is how many hours? 4 hours. So accordingly, 5 to 9 will be 4 hours. That's why it is 1 meter per second. We move on to the next sum. Next sum is sum number 5. Sum number 5. You are given a graph over here. Now, everybody need to take out the textbook for this particular thing, because now drawing the graph and all becomes difficult for me. So it is better that you directly take the help of the textbook and we follow the textbook directly. So you can use the textbook, that is Concise Physics, okay, 9th standard. So you take the first one over here. You can see question number 5. The figure is given to you. It's a displacement time graph where both the sides, they have got this particular values. So it is this way and this way. Now first thing, now you are just going to read the graph. We are not doing much over here. The question is very easy. We are just reading the graph. Let's see what happened, what exactly is given. From the displacement time graph of a cyclist given in the figure, find first average velocity in first 4 seconds. So it is, first one is average velocity in first 4 seconds. What is the displacement in the 4 seconds? It's 10 meters. You can see from here, 4 car representative over here will be 10 meters. So you can see that 4 is 10 over here. So accordingly, it is nothing but 10 meters, and at the start it was 0. So, and the last time it is 4 minus 0. So it will be 10 upon 4 is equal to 2.5 meter per second is the average velocity from 0 to 4. Next is displacement from the initial position at the end of 10 seconds. See, at the end of 10 seconds, where is the body? The body is down at minus 10. So what is the displacement? The displacement is minus 10 meters. So it is here directly from the graph. Displacement at 10 seconds is equal to minus 10 meters. Okay, next one. The time after which he reaches the starting point. Now you can see when does he reach the starting point? Whenever the graph comes to the origin or this particular x-axis. When the graph comes to the x-axis, he is reaching the start point. So first of all, he comes to the start point at 7-second point, and another is at the 13-second point. So the answer over here, third one is that at 7 seconds and 13-second, he is going to reach the start point. So he reaches the start point twice, at 7-second and 13-second. Basically, what was this figure about? The figure was that it is the ball starts over here, or the cyclist starts over here. He goes one direction, waits over there for some seconds, then returns back, reaches here at 7 seconds. This and this is 7 seconds. Then he starts here, goes at other end, which is 10 meters from on the other side, waits over here, and then comes back again in 6 seconds. So basically 13 second from the start point. 0 से start किया, 7 seconds में यहाँ पे पहुँचा, 13 seconds में यहाँ पे वापस पहुँचा. Got it? So that is what the graph is representing over here. The graph over here represents this kind of a motion of the cyclist. Let's see the next one. Question number 6. Question 6. Figure ahead represents the displacement time graph of motion of two cars A and B. Find the distance by which car B was initially ahead of car A, the velocities of car A and B, and time in which the car A catches with the car B. Now this is the figure given to you, two graphs. Okay, one is the first one which is starting from 0 and straight line going over here, so that is A, and one which is starting from 40 and reaching here like this, it is car B. So first question, if you see, the first question is that the distance by which car B was initially ahead. So you can see when A was at 0, B was at 40. So initially car B was 40 kilometers away from car B. Okay, so car B was 40 kilometers ahead of car A. That's the first answer. Understood? Just see the graph. There is nothing calculating. No calculations required. Okay, velocities of car A and car B. How do you find out the velocity from the displacement time graph? Slope. So we have got both things. Now car A. Car A का अगर देखेंगे तो car A is at 4 seconds it is 160. 4 hours. So it is 160 minus 0 upon 4 minus 0. That is 160 upon 4 is equals to 40 kilometer per hour. Car B, this is the velocity. Car A velocity will be, he is reaching 120, but he started from not 0, but he started at 40. So in 4 hours, he is traveling 80 upon 4 is equals to at the speed of 20 kilometers per hour. So velocity B is 20 kilometers per hour. Question 3. The time in which car A catches the car B. You can see from the graph, where is the intersection point of graph A and B? The intersection point of graph A and B is at 2 hour point. So that's why the third answer is at 2 hours, or at 2 hours. The 2 hours is the time, and the time in which the car reaches, that is in 2 hours. So this 2 hours is the answer for A and B to meet each other, or car A catches car B. Finally, fourth one, the distance from start when the car A will catch the car B. So at what distance? So 2 घंटा तो पता चला. At what distance did that happen? It happened at 80 kilometers from the start. So it is 80 kilometers from start. From start of car A. So when the car A started running, from that point at 80 kilometers, the car A and car B caught each other. Okay, so that was question number 6. Question number 7 onwards we'll take in the next video.